Hello students, today I'll be starting a new chapter that is motion in a straight line. So this chapter is related to a branch of physics which we call as a kinematics. Now what does the kinematics states? So kinematics states which is a branch of physics which deals with a body which is moving. Like suppose if you want to calculate the velocity, acceleration, displacement, distance, or any term related with it, this can be only calculated under the branch of physics which we call as a kinematics. So suppose a person is moving in a road, and you want to calculate what is the distance he has moved, or what is the displacement of the person from his home to that position. So how will you know that how much he has displaced? So to calculate the displacement, we need a fixed position from where we'll be calculating. That fixed position, we call that as a frame of reference. Like suppose there are two cars is moving, like suppose they are moving in the same straight road. So one car is moving fast and the other car is moving slow. How will you know that one car is moving slow and one car is moving fast? So for that, we need a fixed frame of reference from where we will be calculating whether one car is moving fast or whether one car is moving slow. Okay, so that is the main point from which we can calculate any other object velocity, displacement, or anything. That is called as a frame of reference. So in this chapter, mostly the topics that we'll be discussing, these are related to the class 9. Like we have discussed in the class 9, like we have the distance, we have the displacement, velocity, we have the acceleration, we have the equation of motion. Okay, so these are the topics that we are going to discuss in this chapter. So the first part that we'll be discussing here, first we need to know what is a scalar quantity and what is a vector quantity. I think everyone knows about, up till now everyone knows about what is a scalar and vector quantity. The scalar quantity are the quantities which has only value and does not have any direction. Like suppose if we consider mass, when we go to a shop, okay, when we go to a shop, we tell that we need a certain amount of like suppose if I want to buy a potato, I'll be telling that I want potato suppose of 2 kg. I'll be not telling that to the shopkeeper that give me the 2 kg potato in this direction. This is not correct. Okay, so the mass has only value, it does not have any direction. So we can consider mass as a scalar quantity. Then if you consider vector quantity has both value and also has direction. Like if you consider the velocity only, so a car is moving in a straight road. So when the car moves in a straight road, it will be moving at a certain speed. Okay, and in a certain distance. So that car will be having a certain value also, and also will be having a direction. So that is called as a vector quantity. Now the first topic that we are going to discuss is about the distance and the displacement. So our chapter name is motion in a straight line. So why it is named as a motion in a straight line? Mostly in this chapter we'll be discussing about a one-dimensional motion. After this chapter we have a chapter called as a motion in a plane. In that chapter we'll be discussing about a two-dimensional motion. Here all the topics will be discussing only about the one-dimensional motion. Remember about that. Now first thing that we are going to discuss is about distance and displacement. I think most of you have remember about this distance and a displacement in class 9 that you have done. So this distance and a displacement, if I consider, first difference is that this is a scalar quantity and this is a vector quantity. This, if I consider, this can be positive, and if I consider the displacement, it can be positive, it can be negative, and also it can be 0. So if I take a certain situation, if you remember the class 9 only, we have example in class 9, like suppose this is your home. Okay, this is your home, This is suppose a market, or suppose we have a shop here, and this is suppose your friend's home. This is your friend's home. From your home to your friend's home, suppose it is having a distance of 10 kilometer. This is having a distance of 10 kilometer. And from the friend's home to the shop, suppose if I consider that it is having a distance of around 4 kilometer. Clear? Now, related with the diagram, I'll be discussing about a distance and a displacement. First situation goes like this. First situation is that suppose you have started from your home and you went to a friend's house. So what will be the distance and what will be the displacement? If I mark this as point O, this is A, and this is B, what will be your distance and the displacement? Distance, remember, is a total path travel. Total path travel. So you can see you have moved from your home to your friend's home. How much path you have traveled? You have traveled a total path of 10 kilometer. That means for the first situation, your distance will be 10 kilometer. Then what will be your displacement then? Distance is 10 kilometer. What will be your displacement? Displacement, always remember, displacement requires your initial and a final position. We have to see which one is your initial and which one is your final position. So this is your initial position, this is a final position. So this will be again 10 kilometer, because you can see the distance between the initial and the final position, that is 10 kilometer. So we have got distance and a displacement for the first situation. Now second situation goes like this. Suppose you have started from your home, you went to your friend's home, then you returned back, and suppose you waited in the shop to buy something, suppose. So when you waited at the shop, which is at a distance of 4 kilometer, what will be its distance and what will be its displacement? So the distance here, it will be, you have moved from your home to the friend's home. How much you have moved? 10. Then from the friend's home to the shop, you have moved by 4 kilometer. That means the total path you have traveled, that is 10 plus 4, it will be equal to 14 kilometer. That means for the second situation, your distance will be 14 kilometer, and the displacement, remember, again I am telling, for the displacement you require initial and a final position. This is your initial position, this is your final position. So initial and a final position, what will be its difference? Total was 10, this is 4. So this part, the remaining part, it will be how much? So it will be 10 minus of 4. So this will be equals to 6 kilometer. So this is your displacement. Now the third situation. Third situation is that you went from your home, we have went to friend's home, then you returned back and you came back home. Okay, now what will be its distance? You have moved forward 10 kilometer and you have moved backward by again 10 kilometer. So 10 plus 10, it will be total, it will be equal to 20 kilometer. That is a distance. Displacement, how much you have done? Initial and the final position both are same. So if initial and final position both are same, then your displacement will be equal to 0 kilometer, because you can consider this is 10, then minus 10, so 10 minus 10, it will be equal to 0. So as I have already stated, it can be having a value of 0, but distance cannot be 0. So this is the difference between a distance and a displacement. Clear? Suppose if I give you one more question, like suppose this is a simple question that you have already got in class 9. One more question, suppose if I give you, suppose we have a circular path and a person is cycling for his fitness. Suppose for his fitness he is moving in the circular path. Suppose this is a circular playground. If you consider this is a circular playground and the playground is having a radius of suppose around 5 meter. As for example, it is having a radius of 5 meter, and to complete the full circle by the person, to complete the full circle, he takes time suppose around 20 seconds. Suppose if I take an example, he takes a time of 20 seconds. He starts from here, he moves the full circle up till here, he takes 20 seconds. Now the question goes like this. What will be the distance and the displacement for the time, suppose if I consider as 50 seconds? What will be the distance and the displacement? Now you can see here, to complete one circle he takes 20 seconds. If he takes one more circle, then he'll be taking 40 seconds. If he takes one more circle, he'll be taking 60 seconds. But in the question it is not given 60 seconds, it is given 50 seconds. That means if I divide this 20 into two parts, so it will be 10 plus 10. That means after completing two circles, the person has completed half of the circle. That means two half of the circle he has completed. So he'll be here. So if he will be here, so here distance it will be. Okay, distance, how much distance it will be? Remember, when we calculated distance in a circle, it will be always considered as a circumference of the circle. He has completed two circles, so it will be 2 into 2 pi r. Then he has completed half of the circle, so it will be pi r. So it will be 2 into 2, it will be 4 pi r, plus pi r, it will be 5 pi r. So radius is already given in the question, so it will be 25 of pi meter. You can place a value of pi and you can see what will be the value. You can 25 into 3.14 also you can do, or 25 into 22 by 7 also you can do. Then if I go for the displacement, remember again initial and the final position. His initial position was this, final position was this, and displacement is always measured as a shortest distance between initial and the final. This will be not in shortest distance, obviously the shortest distance will be its diameter. That means this will be equals to diameter displacement, and that will be 5 plus 5, that will be equals to 10 meter. So this is how we can calculate the distance and displacement of a straight path I have shown, and also I have shown for the circular path. So if you have any doubt related with this, you can give me a question on the comments. Okay, this much for today. We'll be discussing some more topics related with this chapter, that is a motion in a straight line, in the next class. Thank you.